exercise 15.10, find the area of each shaded region. So in this exercise, we just write the equation and then press calculation to get the answer and check whether the equation that we write is correct. And the step in the middle is definite integral. And the definite integral, I assume that you already know how to write it in the previous part uh, exercise. So for here, we just train how to write the correct equation and how to get the answer straight from the uh, calculator. So for this one, it is integrate for the y is the x cubed minus 6x squared plus 9x from 0 until 3. So this is the area. So 27 over 4 is also equal to 6 and 3 over 4. So this is the area, okay, or 27 over 4. Okay, so for this one, is actually, if we want to do the integration, we need to write as 3 to the power half minus x. But in the calculator, we don't need to do that. We just integrate the 3 square root x minus x from 0 until 9. And then the calculator will give us a answer, okay, that is 13 and half. Okay, 27 over 2. So this is the area. Okay. So question C is integrate 3x plus 6 over x squared minus 5 from 1 until 3. So the answer is 6. Yes, correct. Okay. Um, if we do the integration manually, then this y is actually 3x plus 6x power negative 2 minus 5. Okay, so for this one is integration of e to the power x plus 2e to the power plus 2e to the power negative x. Okay, 2e to the power negative x from 0 to 1. So from 0 until 1. So the answer is uh the answer that we get here is this, and the answer provided by the textbook is 1 plus e minus 2 over e. So yes, correct. Okay, same answer. So this is the answer given in the textbook. Okay, but the calculator cannot show something too complicated. We will return in a decimal, and then we check with the answer provided or the answer that you get in the exam, and then you check whether they are the same. Okay. Hmm. Okay. For E and F, for sure, if you use most of the student, if they use their calculator, they won't get the correct answer. Why? Okay, because I let my student to keep the angle unit as degree. But in IGCSE, if not mentioned by default, it is in radian. So you need to do the shift setup, and then number two, angle unit to change to radian. So after you change to radian, then only you do the integration of 2 sine x plus 3 cos x from 0 until pi over 2. Okay, then it will return 5. Okay, if you didn't change the angle unit as radian, then you won't get the answer here. Okay, you don't get the correct answer. So this is integration of 1 plus sine 2x, 1 plus sine 2x from pi over 4 until pi over 2. Okay, so this is the answer. So it's 1.2854, and the answer provided is 2 plus pi over 4. Okay, yes, uh, same. Okay, so this is the area. Mm. Okay, so for question number 2, if we do the integration for this, okay, uh, if in the exam we will have the x squared minus 2x lah. We do the integration for this. So if we do the integration for this, okay, what we have is actually negative value. Okay, so we have the x bracket x minus 2, and then from 0 until 2. So the answer is negative 4 over 3. So the integration is negative 4 over 3. Okay, why it is negative? Because we know that uh, above the x-axis will be positive, below the x-axis is y is negative. So for this one, after we get the integration is negative 4 over 2, 4 over 3, then the area is 4 over 3. Okay, so for the part B also, we will have the same thing. We do the integration of x minus 5 cos x over 2. 5 cos x over 2, and then over 2, mm, and this is from the pi over 3 until the pi over 2. You must make sure your calculator is in radian. When you do the integration, involve triangle, sine, cos, tangent, you make sure you have a radian here, R instead of D. Otherwise, you won't get the correct answer. So the answer that I get is this, and the answer provided by the textbook is the find square root 2 minus 5, and then minus 5 pi square over 72. Okay, so this is the answer provided. Yes. Okay. Mm. So sometime I will write this way. The area is equal to modulus of this, then it will become this. Okay. So for this equation, I can do it this way. I just have the ABS in my calculator. So shift bracket here, we have the ABS. ABS is the absolute value. Then we have the modulus sign here. And integrate of the 4 over x plus 2 from 0 until 3. And it will return the uh, magnitude, the area, okay, without the sign, negative sign. Okay, so this is the answer. So the answer provided by the textbook is 4 ln and then 5 over 2. Okay, 4 ln 5 over 2. Okay, yes, correct. Mm. So, and so uh, I want to repeat again. We want to train how to get the correct first sentence, and how to get the correct answer from the calculator to check the answer. What we want to train here is this. So for the proper full step, okay, the one I will do, I will write when I do the past year question, 2 over 2x plus 3, 2 over 2x plus 3, 2 over 2x plus 3 from, oh, oh, I missed out the integration sign. So what we can do here is I write a bracket here. So in front of this, I write shift insert. You can see that the cursor changed to this, and then I write integration. Mm. So this whole thing is inside the integration already. So from -1 until 1. Okay. So the answer is 1.609, and this is ln 5. Ln 5. Yes, correct. Mm. So this is the area. Okay, so for question number 3, we will have the area 1 and we have the area 2. Okay, so uh, if you want to uh, do the integration manually, then what I will do will be I expand this one. So it is x plus 2 multiplied with x squared minus 1. So we have the x plus y multiply x minus y, then will be x squared minus y squared, x squared minus 1 squared. Okay, then we expand here again, then it will become x power 3 minus x plus 2x squared minus 2. Okay, so for this one, we want to integrate the x plus 2 multiply with the x plus 1 and multiply with the x minus 1, okay, from -2 until -1. I get 5 over 12. Okay, so if I do the same integration, so I integrate the x cubed minus x plus 2x squared minus 2 from -2 until -1. I will get the same answer here. Okay, this is area 1. So for area 2, uh, we need to put, if you don't, we need to put modulus. So modulus of this, so just now this equation, I changed the boundary from -1 until 1. Then I have the -8 over 3. So the total area of shaded region will be 5 over 12 plus 8 over 3. So this one is 8 over 3. So we have the 5 over 12 plus 8 over 3. Then the answer will be 37 over 12. Then this is 3 and 1 over 12 units square. Okay.